Howdy once again, it's tubalcain, your YouTube shop teacher. Welcome back to the shop. And in this rather lengthy multi-part video, I'm going to machine a drill press vise from these raw castings. Now this vise will be approximately 2.5 inches wide, and it is about the size of the ubiquitous Palmgren vise, of which they must have made millions. And this is a Japanese one here, and here's a Yankee vise, a little bit smaller. And this could be made either with V threads or with Acme threads, but of course I'm going to make it with V threads because I do not have an Acme tap. You may recall several months back in one of my videos where I went to an auction, and among the plunder were these two castings. I bought them with great enthusiasm. I recognized them. My classes made many of these over the years. I made one many years ago when I was in high school. These were cast and marketed by a company in Cedarburg, Wisconsin called Casting Specialties, a division of C.F. Struck. This one has been partially machined before the man died. He machined the bottom and part of the sides. He didn't remove all of the rough casting here. And this is nice gray iron castings. They're really beautiful castings. These would originally have come from Casting Specialties with wrapped in newspaper and included all of the other raw products that you might have needed for this, the bar stock, the screws, just everything, including complete instructions and blueprints ready to go for students to get to work. And these were designed by Mr. Struck, Clarence Struck. He, as far as I understand, was a former industrial arts shop teacher and had a great ability to come up with these projects, design them. There was at least 20 different projects. Now, what I'm going to do before I start this, I'm going to bloviate for a full 5 minutes about Struck and Mr. Struck, the company, and Casting Specialties before I start machining here. So this is a fair warning. At the bottom of the video here, I will give you the time mark if you want to just skip over this and get right into the meat of the project here. But for some of you, stay with me. See you in a minute at my computer. I'm sitting at my computer now, and I've done quite a bit of research here to show you these things if you're interested. This is Clarence Struck, C.F. Struck. And this is an ad from Popular Science from 1952, and they ran a lot of ads in Popular Science, Popular Mechanics, but mainly they were aimed at marketing these products to school shops and so on. So there was a magazine called School Shop, and that is where they also advertised. And they had quite a thick catalog, and I wish I had a copy of that, but I do not, to show you, that showed their whole line of products, which was considerable. Now notice that the address here is Milwaukee, Wisconsin. Well, later it was Cedarburg, Wisconsin, and it just so happens that Cedarburg was my mother's hometown, and we visited there often. So in about 1959, my dad, being a shop teacher, decided, well, I'm going to call up Clarence right here in town when we were visiting and meet him. So my brother and I and my dad drove out in the 58 wagon to Casting Specialties, just a small building in Cedarburg, and we met Mr. Struck here, who was a very nice man. This is a picture when he was much younger, and he had gotten out of a teaching shop and into this business here, which I'll talk a lot more about here in a minute. And he received us warmly and talked, but of course I'm just a 16-year-old boy, and I'm wanting to get out of there, but I was very disappointed to find out that they didn't actually make the castings there. It was not a foundry. Those castings were probably made in Milwaukee or wherever he could get them cast the cheapest. But in the background was an old woman sitting at a table, and she was wrapping the castings in newspapers, alternating between the Ozaki County News and the Milwaukee Journal green sheets. This ad appeared in Popular Science in 1980, and you might even remember this. There were very small ads in the back of magazines, and this was one of their products here, which was a power hacksaw. And in fact, I made one of these when I was 16 years old in my dad's shop. Well, he was the teacher. And notice the vise on here. This vise is the same vise that I'm going to make in this video. And also notice here that the address is now Cedarburg, Wisconsin. And this ad was found on Vintage Machinery here. This ad, also on Keith Rucker's Vintage Machinery, came from the 1950 School Shop magazine, and that was a magazine that all shop teachers received, and I subscribed to it for 30 years, so it was a good magazine. So here's an ad in there, and that was for their drill press, which at that time, in 1950, was only 20 bucks. Notice that it weighed 70 pounds. However, the 20 bucks was way too expensive for most students to purchase for their class. So I don't know how many of these they sold, but they also had grinders and buffers and vise, woodworking vices, just a lot of different products in that vise. I don't even, or in that catalog, I don't even remember how many items, but quite a few. And then it would tell you what equipment that was required and to make it, and all of that. And see, the drawings and instructions were included, and they were very well done and easy to read. I'm back on Google Books now, and this is an article that was in the 1968 Popular Science magazine. You could look it up here if you had a notion to, but there it is, all how to build this. Now, it only had an 8-inch blade, and I must confess that it was it was a toy, but it would cut, but probably not any faster than if you used a hand hacksaw. But I wanted to show you the vise there. Also note here that it is sprocket and chain driven, where the ones sold to the high schools were gears. So I cut my first gears, a large gear and a smaller spur gear to drive this. And here's a complete article on how it was built. There's the raw castings, and notice the vise casting here, the main casting, and there's the jaw and all the parts included. And that was 20 bucks at the time, which would be equal to 120 now, and also here showing how to make it. Also, that's all there is here. Notice here that for the purposes of somebody building this in their basement just with a drill press, that the bolt here was merely a hex head bolt bought at the hardware store and threaded down closer to the head. And also that sprocket and chain used so that it wouldn't be necessary for you to cut a gear, because if they were requiring gear cutting here, that would eliminate most of the market for this, in the home market anyway. Now I'm on the YouTube site, and if anybody wants to look at this, just do a search here for Power Hacksaw Flea Market Find, and here's a man that bought one at a flea market for a few bucks, and there's the vise. And he resurrects it so that it will run. I don't think he paid much for it. And don't worry, I'm not going to show you this whole thing. You can look at it yourself if you want, but he gets it running. And as far as I'm concerned, he's got it running in the wrong direction. The rotation here should be the other way so that there would be more downward pull on the backward stroke, because it should cut on the backward stroke, not the forward. But I'm getting sidetracked here, because what we're really interested here is in this vise. Now, when I visited Mr. Struck, they already, and that probably was 1959 or 60, they already were selling versions of this little crawler tractor, and CF Struck still has a website here, so if anybody wants to go to that, look up struckcorporation.com, and they still advertise these kits to make these little tractors. They had a little Jeep as well. I don't know if they still do. And there's videos on this, so Struck is still around. I'm sure that Mr. Struck is long gone. Matter of fact, he was born in 1918, so he'd be 100 years old if he's still living, which I kind of doubt. So look this up if you're in the mood. All right, at this point, going back down into the shop and start actually making the vise. Thank goodness you're thinking. The question is where to start. Well, I made a lot of these over the years, plus another version of this out of aluminum, so the process is very simple, similar. Now I'm going to set the jaw aside for now, because I like to make the main body first and then make the jaw to fit the body. And the reason for that is that if you try to hold the dimensions for that in a school shop, the kids are just all over the place on a slot like this as far as dimensions. So it's best to machine this secondly and make it fit. So I'll set the jaw aside for now, and we'll talk just about the main body. Many of the dimensions will just be nominal dimensions and does not really matter, but this is a 1/2 inch diameter screw, and I do remember that 1/2 inch is the size. Now, if I can just backtrack a little bit to casting specialties, I was inspired, along with my brother, by the whole system by which Strux marketed these castings, and I know the hunger there is by a shop teacher for projects for the kids to make. So in the late 60s, my brother and I formed a company called Peterson Products, and we had a complete line, that is 10 different projects, but we did not sell castings. Castings were too expensive. We were trying to get the price down, so we sold foundry patterns because often school shops had a foundry as well. So we had projects for a C-clamp, 2 vices, a large one and a small one, one about this size. And this is all because of Clarence Struck. And we had a sander and a bandsaw, just a lot of them. I wish I had pictures to show, but when I closed the company out, I was so sick of it and I didn't save anything. And I had complete instructions and blueprints as well as Mr. Struck did. So he was very influential, and he would never have known anything about this, but we sold those thousands of them. So they were in every doggone school shop in the United States, but they were plaster, and the idea was that the teacher would take these very delicate plaster patterns and reproduce them into aluminum patterns that could then be used to make the final casting. That was the whole deal. Now, because of that, and along with that big micrometer that I used to make, and I've talked about that too, I was able to retire when I was 55. The question here in my mind now as I start this is that how accurately was this machined by the dead man? Well, actually it's been surface ground. And he was going to take the taper off. Remember, all castings are tapered. And he removed part of it. So I don't know what order that he did this in, but I'm trying to think this out, and how accurately did he do it? Well, setting it here on the surface plate, wiping everything off, and using a little Starrett square here, I've already checked it. Well, I got quite a bit of taper there yet, so yeah. So holding the square up against here and a light behind here, it appears to be very square. The casting is a little rough, although I don't mind that at all. That's not really that rough here, but on this side there's a bit of a blemish from the casting process, so I think I'll grind that off and wire brush some of the surface rust off because it's been in storage, well, for maybe 40 years. And then I'm going to spray paint it right here and here so that is done. Now later on a hole or a slot could be drilled on each end. I'm not going to do that, but that's probably what that flange is for. Very nice castings. This is my very accurate Taft Pierce angle plate. So I'm again checking it for squareness here, and it is setting square. I'm not able to tilt this or push it up because it is virtually square, and then using the last word indicator here, and I got it zeroed out. I'm going to hold this against there just in case. You see a little fluctuation there, don't you? Not very much. And I'll run it up here to where the rough casting is, so there's about, well, really no difference. You know, I like a last word indicator because it's in thousandths, not tenths of a thousandth. And sometimes when you use a tenth of a thousand test indicator, you're going to see a lot of fluctuation, and it kind of scares you into thinking your work is inaccurate, and a tenth of a thousand is so tiny that I like to use this for most of my work. And that is the world's favorite test indicator anyway. Probably sold more of those than anything. So off camera, what I'm going to do now is, well, before I go off camera, I'm going to take it over to the Bridgeport mill and show you how I would do this if it hadn't already been machined. The very first thing I would have done is to take it over to the 6-inch Rockwell Delta belt sander, and with a rather coarse belt I would have sanded the bottom of this, just like this, just enough to clean it up. Wouldn't even have to take it down so that it was totally true. It would be only semi-true anyway. This isn't all that accurate, but that's what I would do, would be to clean that up. An alternate would be to draw file it, but that could change your dimension from one end to the other. And it's not very critical. Now I'm at the Bridgeport, and I have to emphasize that there are many different ways to do this. This is just the way I do it. You can do it any old way you want, but this method works. But there's always people that want to argue, why didn't you do it this way or that way? Well, okay. I also, while I was at the belt sander, would have cleaned up one of these sides just a little bit, because you know a rough casting can have all kinds of little marks on it. Now one side of this or the other would have had the gates on it. So I probably would put the gate side up and mill that off. So just arbitrarily marking this as the bottom side, because you want a side that is relatively true to lay into the vise. And notice that I'm putting the back surface here up against the fixed jaw, not the other way. That's fairly important, although it might be arguable as well. Now, when I tighten this down, I don't want to just tighten it on this surface, and you know, this is higher than this. So, just using a piece of packing here, just a piece of stock, I like to, right in the middle there, tap it down a little bit. I don't have my lead hammer here. Where's my brass? I would tap it down just a little bit, and this needs to be below the surface so that doesn't interfere with the cutter. Tighten up the vise, and I would machine this side off. Again, you wouldn't have to take all of it, totally clean it up, as this man didn't with the grinder, but I probably would, and that takes off the taper or the draft from the pattern. So I would clean that side up, then take it out, and of course there would be a burr. I would remove the burr, and now it could be flipped end over end like this. I'd use this again, although it probably isn't necessary anymore. And then I would machine that side. That brings me pretty much up to the point where the man died. Now off camera, that's all I'm going to do for today. I'm going to remove that, like I told you, and wire brush that and paint it. And I'm not worried about masking it, because I don't care if I get the paint in other places. And that's the whole reason why I'm doing this, is that later on I could do the painting. You know how I hate to paint. I could do the painting when the whole job is done. However, then it would have to be masked. Well, I got the castings back from the paint shop, and they're looking good. I was just thinking, I don't know why I'm doing this. I already have many more vices than I have virtues. Here's the game plan. Now, it appears that the man used a surface grinder. Maybe it was a lady to machine this. So he or she could not get up all the way to the fixed jaw here, so that has not been machined. That's still rough. I probably will not machine this rough casting. I actually like the looks of a casting. That's pretty awesome, I think. But one thing I haven't talked about now is that cast iron castings have what they call a fire scale. At least that's the term I use. And it's extremely hard and tough, and sometimes there's bits of sand stuck in there. It's very, very hard on cutters. So I'm going to use a carbide cutter and machine this surface and the bottom, taking off as little as I can off this, because I don't know how much has been removed. Well, I do know. You can see there, it's probably only about a 32nd. So that'll be cleaned up, and that'll be cleaned up in one operation. Over to the BP we go. Here's the setup, 3/4 inch carbide end mill at 1000 RPM, and I'm using 1.5 inch parallels to raise the work up enough so that I won't hit the vise when I mill in here. If you have never machined cast iron, there is no need for lubricant or coolant because it is self-lubricating because of the large amount of graphite and carbon in it. It is extremely messy as far as getting on your hands. It's just black. So there's some things I don't like about it, but it sure does machine nicely. Enough talking, here we go. I'll just bring the cutter down onto the work. Then I got the approximate depths and I'll raise it up just a few thousandths. Next up, I have two slots to mill, the wider slot and the narrower slot where you see my forefinger. And I'm going to do the wider slot first, and you'll see why in a minute here, just so I have clearance and can see what I'm doing as why. I've done some layout. I don't know if it'll show up. The wider slot will be 13/16 wide, and the narrow slot will be 9/16 wide, and I just arrived at those by how much material was left here. So some of that is just guesswork, but it'll work. Now, even though I own 50 or more parallels, I don't have the size parallel that I need that is the right length and the right height. So what I'm doing here is using two Brown & Sharp V-blocks, and I already checked them to see that they're a match set, and they are. They're just perfect. So the casting will set on those, but the problem is that I will want to do both slots in one setup. I don't want to ruin the cutter and my V-blocks, so I've taken the time to make a packing, that's aluminum, so I can mill right into that a little bit. And then I know where I'm at, and that'll sit right on top of it like that, tighten it down, and it's ready to mill. This is a 3/8 carbide end mill, and I've already set the depth just enough to clean up the bottom of the slot, and I'm going to try to take an equal amount off of each side so that I end up with 13/16, and I'll check that with a caliper, and I'm ready to go. I won't show it all, and I'm just concerned with the wide top slot at this time. This will be the final pass. I already did the other side, so I'm just coming down the side closest to me. And from time to time, I've been using the shop vac to get those chips out of there because they really build up in here. I certainly don't want to blow those horrible cast iron chips around the shop. They're so dirty. Alright, let's see what we got here. I'm wanting 812 thousandths about. And I'm at 800 thousandths. So I'll take a light pass on each side, and then I'm down to the size. That isn't very critical. And then I'll start on the small slot. Okay, the wide slot is done, right at that dimension, and I'm ready for the narrow slot that will be all the way through the bottom. And it's 9/16 wide, so I'm trying something a little different. I'm using a 9/16 end mill. It might be the first time in my life I ever used the 9/16 end mill. So being centered left to right there, I'm going to plunge it down until I actually cut into that aluminum waste stock that I talked about a few minutes ago. And then I just intend to go back and forth to clean it up, and we'll see how the finish is. And I've got it marked as far as the extremity is concerned. So I hope this will be easy and I'll be done in a minute or two. Okay, the slotting is done. Let's see what we got. See, there's the aluminum packing that was in there. Looking pretty good, I think.